The process of manufacturing phones in a factory involves multiple stages, from raw material sourcing to final assembly and quality control. Here's a breakdown of the key steps. 1. Raw material sourcing. Essential materials such as silicon for chips, lithium for batteries, glass for screens, and rare earth metals for components are sourced from suppliers. These materials are refined and processed to be used in different components. 2. Component manufacturing. Chipset production. The processor and memory chips are manufactured in semiconductor fabrication plants fabs, using complex photolithography processes. Display manufacturing screens LCD, OLED are produced in specialized factories. Battery production lithium-ion or lithium polymer batteries are assembled in controlled environments. Camera modules, sensors, lenses, and image processing units are made and tested. 3. PCB printed circuit board assembly. The motherboard is assembled, with processors, RAM, and other components mounted onto it using automated robotic systems, surface mount technology, SM. Soldering is performed to connect components, followed by automated optical inspection. 4. Phone body and frame production. Metal or plastic frames are molded, CNC machined or frames undergo polishing, painting, or anodization for durability and aesthetics. 5. Final assembly. Automated and manual processes integrate the display, battery, camera, buttons, and motherboard into the phone's body. Screws and adhesives secure the components, and the device is sealed. 6. Software installation. The operating system, for example, Android, iOS, is flashed onto the phone's internal storage. Firmware and factory test software are installed to check for functionality. 7. Quality control and testing. Functionality tests. Checks for screen responsiveness, button operation, and connectivity Wi-Fi, Bluetooth, network signals, battery and charging tests. Verifies battery performance and safety. Drop and durability tests. Some models undergo drop, water resistance, and impact testing. Camera calibration. Ensures color accuracy and focus performance. 8. Packaging and distribution. Phones are cleaned, packed with accessories, charger, cables, manuals, and placed in branded boxes. The final products are shipped to warehouses, retailers, and distributors worldwide. Detailed process of phone manufacturing in a factory. The manufacturing process of a phone is highly intricate, involving precise engineering, automation, and human labor. Below is a deeper dive into each stage of production. 1. Raw material sourcing. Modern smartphones require a variety of raw materials sourced from different parts of the world. Metals, aluminum frames, body extracted from bauxite, copper wiring, circuits, mined in countries like Chile, gold and silver conductors and circuits, used for internal wiring, rare earth elements, neodymium magnets and speakers, vibration motors, tantalum capacitors for power regulation, silicon used to make microchips CPU, GPU, memory, lithium and cobalt, essential for lithium-ion batteries, mainly sourced from Africa and South America. These materials are refined and sent to various component manufacturers. 2. Component manufacturing. Each phone consists of several key components manufactured in different factories before being assembled. A processor and semiconductor fabrication. The processor, CPU, GPU, is the brain of the phone, manufactured in semiconductor fabs, for example, TSMC, Samsung, Intel. The process involves wafer fabrication, where silicon is turned into tiny transistors through photolithography, UV light exposure on silicon wafers. Advanced chips are produced at 3 nanometers or 5 nanometers technology nodes, allowing better performance and energy efficiency. Display manufacturing. OLED and LCD screens are created in dedicated factories. Samsung Display, Bo LG Display. Processes include thin film deposition, color filter application, backlight assembly for LCDs. Displays undergo touch sensitivity calibration and color correction. C. Camera module production. Leading suppliers like Sony and Samsung manufacture higher resolution sensors, lenses, image signal processors, and stabilization mechanisms. OIS, EIS are assembled. Camera modules are tested for clarity, autofocus, and low light performance. DI battery production. Lithium-ion or lithium polymer batteries are made using cathodes lithium cobalt oxide and anodes graphite. Batteries are tested for capacity, safety, and thermal performance. 3. PCB printed circuit board assembly. Designing the PCB layout. Engineers design the PCB layout, determining how all components are connected. Multi-layer PCBs are created to fit processors, memory chips, sensors, and power circuits in compact spaces. BSMT surface mount technology. Process. Automated machines place microchips, resistors, capacitors, and transistors onto the PCB. Solder paste is applied to secure the components. The PCB is heated in a reflow oven, melting the solder and bonding components. Optical inspection machines check for defects. 4. Phone body and frame production. A metal plastic frame manufacturing. Metal bodies, for example, aluminum RCNC machined, polished, and anodized. Plastic frames are injection molded and painted. Glass backs on premium phones undergo chemical strengthening, for example, Gorilla Glass. B. Button and port integration. Power and volume buttons, SIM tray slots, USB-C lightning ports are fitted. Waterproof sealing is added for IP-rated devices. 5. Final assembly, a component integration. The display, PCB, battery, camera, and other parts are assembled into the phone's frame. Screws and adhesives are applied using robotic arms. B. Software installation. The OS Android iOS is installed and customized for the phone's hardware. The firmware is flashed onto the device's memory. 6. Quality control and testing. A. Hardware testing. Basic functionality tests. Ensures the processor, RAM, and storage work correctly. Button testing. Checks tactile feedback and responsiveness. Touchscreen calibration. Tests accuracy and multi-touch capability. B. Connectivity testing. Wi-Fi, Bluetooth, and cellular connectivity are tested in anechoic chambers. Antenna performance is verified to ensure strong signal reception. C. Battery and safety tests. Charge cycles are tested to ensure battery longevity. Thermal tests check for overheating risks. DI durability and stress testing. Drop tests. Phones are dropped from various heights to test durability. Bend tests. Pressure is applied to check structural integrity. Waterproofing tests. Some models undergo IP certification for water resistance. E-camera calibration. Lenses and sensors are adjusted for sharpness, color accuracy, and autofocus performance. Eye-enhanced features, for example, night mode, are tested. 7. Packaging and shipping. A packaging process. Phones are packed along with accessories, chargers, cables, manuals. Protective films are applied to screens and backs. Serial numbers, barcodes, and IMEIs are printed for tracking. B. Global distribution. Phones are shipped to warehouses, retail stores, and customers worldwide. Supply chains coordinate air, sea, and land transport. Conclusion. Phone manufacturing is a highly complex process involving cutting-edge technology, automation, and strict quality control. Each step, from material sourcing to final assembly, plays a critical role in ensuring that the final product is functional, durable, and ready for consumers. Factory automation, environmental impact, and supply chain logistics in phone manufacturing. Modern phone manufacturing is a combination of highly automated processes, environmental sustainability efforts, and complex global supply chains. Below, we'll explore these aspects in detail. 1. Factory automation in phone manufacturing. Automation plays a crucial role in increasing efficiency, precision, and consistency in phone production. Robotic assembly lines. Surface mount technology, SMT machines. Automated machines place tiny electronic components on PCBs with micron-level precision. Pick-and-place robots. High-speed robotic arms handle delicate components such as camera modules and sensors. Laser cutting and welding. Used for precise shaping of phone frames and micro-welding of connections. BAI-powered quality control. Optical inspection systems use AI and high-speed cameras to detect defects in chips, circuits, and displays. X-ray scanners check soldering quality inside motherboards. Machine learning algorithms analyze production data to predict and prevent failures. See human-machine collaboration. While automation handles precision tasks, humans are still needed for final assembly. For example, placing batteries, attaching screens, visual inspections for aesthetic defects, software debugging and calibration for performance tuning. 2. Environmental impact of phone manufacturing. A carbon footprint and energy consumption. Smartphone production contributes approximately 80% of a phone's total lifetime carbon footprint, due to material extraction, processing, and manufacturing. Chip fabrication is extremely energy-intensive, requiring thousands of kilowatt-hours per wafer. B. E-waste and recycling challenges. Over 50 million metric tons of e-waste are generated annually, with less than 20% properly recycled. Phone components, batteries, circuit boards contain toxic materials that can contaminate the environment. See Sustainable Manufacturing Initiatives. Recycled materials. Apple, Samsung, and other manufacturers are using recycled aluminum, rare earth metals, and plastics. Green energy factories. Some factories are powered by renewable energy, for example, Apple's carbon-neutral facilities. Modular and repairable designs. Brands like Fairphone promote easily replaceable parts to extend a phone's life cycle. 3. Global supply chain and logistics. A. Supply chain complexity. A smartphone consists of hundreds of components sourced from dozens of countries. Key suppliers include chips, Taiwan TSMC, South Korea, Samsung, USA, Qualcomm, Intel, displays South Korea, Samsung, LG, China Bow, batteries, China, South Korea, Japan, cameras, Japan Sony, South Korea, Samsung. B. Manufacturing hubs. Most smartphones are assembled in China, Foxconn Pegatron BYD, but production is expanding to India Samsung, Apple Xiaomi plants, Vietnam, Samsung, Apple suppliers. Brazil regional manufacturing for South America. C. Logistics and distribution. Once phones are manufactured, they are shipped via air, sea, and land transport. Challenges include supply chain disruptions, for example, chip shortages, trade restrictions, rising shipping costs, customs regulations in different countries. Conclusion: automation enhances precision and efficiency in production. Environmental concerns are being addressed through recycling, green energy, and repairable designs. Supply chains remain complex, relying on global coordination for raw materials, component production, and assembly.